A couple of, I mean, where I show the idea, but let's say I like to look at 36. What do you think about 36? Okay, 36 on page 98. Any questions for me? Any questions? Please don't be shy. If you need more examples from any type, please let me know, and we will look at more. So here we have limit as x approaches 2 from the left of x squared minus 2x over x squared minus 4x plus 4. How do we start? We're given a limit. We're asked to determine it. What is the starting point?
Plug into.
Yes. Yes, it's not a contradiction. We have to do that because there are so many different types of limits. If I plug in 2 and I get 1/2, I'm done. I don't have to do anything. Okay, so let's plug in 2 at the top.
Zero.
Perfect. Let's plug in 2 in the denominator. Perfect.
Zero.
Before we continue, before we look at anything else, I'm going to ask you, and this is a very important concept, I'm going to ask you which factor is the one that creates 0 over 0? Indeed, x minus 2. When we plug in 2 in a polynomial and we get 0, that polynomial has a factor of x minus 2. Let me write this note for you. It's very important. When p of 2, a polynomial evaluated at 2 is 0, p of x has x minus 2 as a factor. The remainder and factor theorem. Okay, what if I plug in p negative 3 and I get 0? Can anyone give us the factor that p of x has? P of x has a factor of x plus 3. Awesome. So coming back to our limit, if it's 0 over 0, is there hope? There's no guarantee. But is there hope for the limit to exist?
Yes.
The answer is yes. Which factor must be eliminated completely from the top and the bottom, at least from the bottom, for this limit to be a number? X minus 2. So now we know. So from here I'm going to continue on the next page. So limit as x approaches 2 from the left. Can anyone factor out x minus 2? We know it's there. We plugged in both polynomials 2 and we got 0. So top and bottom have to have a factor of x minus 2. So how do you factor the numerator? X in front, very good. And what about the denominator?
X minus 10.
Squared, correct?
Yeah.
Very good, awesome. Well done. So now I will simplify one of those. And I have limit as x approaches 2 from the left, from x over x minus 2. I completely simplified the top and the denominator by the same factor. Now I plug it in again. What do I get?
2
So as I said, there is no guarantee. And we know for sure that the limit does not exist. It's either positive infinity, negative infinity, or DNE. Now look, 2 from the left. Can you give me a number very close to 2 from the left of 2?
1.9.
1.9. The top, still positive. The bottom?
Negative.
Perfect. So positive over negative. So the answer is?
Negative.
Negative infinity. Perfect. I want to come back here for a second. I just want to clarify one more thing. If the limit from the right is negative, left from is negative infinity, and the limit from the right is positive infinity, or just one of the or the other, what do you conclude about x equals -1 for this function? Actually, for the original function, is a Exactly. If one of the sides goes to infinity, it must be, or both, must be a vertical asymptote. Please edit in. Also, what do you conclude for this function about x equals 2? For this function, the problem 36, what do you conclude? What is x equals 2 for this function? Vertical asymptote. A VA, vertical asymptote. Any questions? Any questions? So in WebAssign, 2.1 and 2.2 must be finished by Thursday. If you encounter any situation that you would like us to discuss it in class, please bring it over. Please. Any questions?
You want us to do this?
And that one, please.
Okay.
Yes. And I'll come up with another quiz for you just to make sure that the difference quotient is very clear for quadratic, radical, and rational functions. Okay. 2.3. The limit laws. There are 11 limit laws. The number is really not important. We are going to, they will become second nature, you'll see very shortly. So what are the limit laws? What are we talking about here? So let's assume that we have two functions for which f of x and g, and f of x and g of x, for which we have the limit of f of x as x approaches a, let's say is a number, it exists, it's a number L, and let's say the limit of g of x as x approaches a from either side is another number, uppercase M. So what is the scenario here? Well, we have two functions. We have a number a, a value of x, a, and we say, well, the assumption is that the limits of f and g when x approaches a from either side, they both exist. There are two numbers. They can be the same, it doesn't matter, or different. And here is the first limit law. Limit number 1. As x approaches a from either side, from g of x, I meant to write f of x first, it doesn't matter. Sorry about that. I rushed. So the limit of the sum of two functions whose limit of an x when x approaches a and when x approaches a exists. So the limits exist for each function. So the limit of a sum will be the sum of the limits. So the limit of a sum will be the sum of the limits. Does it make sense? But we will not be able to use this law if the two limits do not exist. And here's an example for you. Of course, they can also be one-sided limits. So here's an example. Limit as x approaches 0 from the left, from 1 over x plus 2x. Can I write this? Can I write it or not?
Yeah.
Careful. The assumption is not fulfilled here. This limit does not exist. It's 1 over 0. So part A of the assumption is not fulfilled. This is not a number.
Because it doesn't exist.
right? So in this case, sorry, I cannot apply the limit law. In this case, the limit of a sum is not the sum of the limits, because this condition is not fulfilled. The limit of this is not a number. It does not exist. Or it's infinity. Number two, it's the same with the difference. So limit of f of x minus g of x as x approaches a from either side is limit of f of x as x approaches a minus limit of g of x as x approaches a. Of course, the assumption has to be fulfilled. Any questions? Questions? Limit law number 3. Limit of a constant c times a function f. What do you think this will equal to? Exactly. Great job. Thank you. C times the limit of f of x as x approaches a. Here's an example for you. Limit of 5x as x approaches 2. This is the same with 5. Limit of x as x approaches 2 from either side. Because it's a constant times a function. Okay. Number 4. Limit of f of x times g of x as x approaches a from either side. A wild guess. No, we're not distributing because it's not the distributive law or anything like that, but this is the same with. So the limit of a product is the product of two limits. Limit of f of x as x approaches a, limit of g of x as x approaches a. Very good. The limit of a product is the product of the limits. And I lost my page number. What was it?
Or number 4.
So where am I? 11. Okay. What do you think will be next? We looked at the sum, we looked at the difference, we looked at the product by a constant, we looked at the product of two functions. What do you think was next?
Function.
Of course. Good. What do you think this will equal to?
The limit of f of x.
Of course.
Over the limit of.
Of course. Of course. Common sense. However, there is an if here that we did not have before. Can anyone tell us what is the if all about?
That g of x is 0.
Absolutely. The limit of g of x cannot be 0. Because then we encounter the same situation. Okay, now we're getting a little bit more sophisticated. Limit of f of x raised to a power n as x approaches a from either side. N positive integer. Say it again.
Does it go to the front of f of x?
Not the power. No, it's not the same thing with a constant. The constant, yes. Yeah, it's n. I'm sorry. I confuse my students with that n. I'm sorry. It's n. You can write m. It doesn't matter. I will come back to this property several times throughout the course. And this is a theorem. For now, let's keep it in mind that or remember it as the swapping of the, what did I swap? Of the, yes, the operators. So the limit was outside, and now it's inside. The limit was outside of the function, and now it's applied to the limit. So what I did, basically, I put the limit inside, and I kept the n outside. That's the swapping of the operators. And we're going to use this several times. Okay, next one, number 7. The limit of a constant as x approaches a. The limit of a constant as x approaches a from either side.
Constant.
Of course. Number 8. Now this is, I don't even think that this should be a specific limit, but completely separate as a limit law, but that's okay. Let's use it as is. Now imagine that this is just plain x, nothing else. What would you say? What I should do?
Put X in the brackets.
Limit as x approaches a from x and everything raised to n. Right? Because now the function was just plain x. So what is the limit as x approaches a? Of course, n has to be a positive integer. Well, we looked at a similar example. What is the limit of x as x approaches a equal to? What does this equal to?
8
Very good. So this limit is a to the nth power. Any questions? Okay, 2 more. Of course, now radicals come into play. And that's it. We had powers, we had products, we had ratio, we had sum and difference. Of course, this is another type of power, a radical. So limit the nth root of x as x approaches a, as a simple example. And then the last one is with a function. And of course, n is a positive integer. Okay, so what do you think of this one? I'm swapping the operators again. What operators am I swapping?
The n root.
Yes, the nth root of limit of x as x approaches a. Of course, this is allowed under certain conditions, and we'll talk in this chapter about continuity. That's a mandatory condition. Okay, so then, what would you write? What is this?
The n root of a.
The nth root of a. Perfect. And what is this? Okay, we're swapping the operators. The nth root of limit of f of x as x approaches a from either side. And it will be the nth root of L. Because the limit of f of x as x approaches a is L. And I didn't forget there is one more, number 11, but it was already incorporated in the previous ones. So limit of x as x approaches a. We already used it several times. Okay, so what will you write? We used it already. A indeed, very good. Okay, so let's look at a few examples. You choose. Evaluate the limit if it exists. I know we have just 3 minutes left, so let's see if we can go at least through one example. Yes, please. 25. 25, very good. Let's do 25 and then we stop. 25 on page 107. And we are given limit as t approaches 0 from the square root of 1 plus t minus the square root of 1 minus t divided by t. And yes, I'm going to ask you, what do we do first? And yes, you have to say, plug it in. And yes, I'm going to plug it in. What do I get?
The limit is
Indeed. Is there hope?
Yeah.
Yes. Is there a guarantee? No. Okay, which factor? I'm expecting to simplify from the top and the bottom for sure. Because when I plugged in t, when I plugged in 0, I got 0. T. T is the factor we have to get rid of. Otherwise, the 0 over 0 will not go away. So keep that in the back of your mind. So what do we do with this? Yes, absolutely. So we multiply by the square root of 1 plus t plus the square root of 1 minus t over the square root of 1 plus t plus the square root of 1 minus t. So then this is limit t approaches 0. I will copy the denominator, which is easy. And please give me the numerator. The numerator is?
1 plus 2 minus 1 minus 2.
Yes, but in parentheses.
Right.
Because we need to distribute -1. Very good. Last step. So this is limit t approaches 0. The numerator has 1 plus t minus 1 plus t divided by t, and in parentheses 1 plus t plus the square root of 1 minus t. Yes. Please do not cross out terms. I know it's easier instead of writing one more time. Let's write it one more time. And only now simplify the culprit. The culprit is t. Because when we replace t by 0 all the way, we got 0 over 0. And that is the factor that must go away. Now, please plug in 0. The top goes to 2. The denominator goes to 2. So then the limit is 1.